All right, here's systems of equations by graphing. No worries, man, we got that. And you know, whether you do it with the table or with slope-intercept form is really up to you. I'm going to do it both ways just because both equations are written in standard form. So I'm gonna change the first one into slope-intercept form. So that first one, I'm going to change it into slope-intercept form, right? So let's write it over here so we can work with it, though. 2x plus y equals 1. And hopefully you guys can see that just changing this into slope-intercept form should be pretty quick, relatively painless. You know, subtract 2x from both sides, 0, the 2x is out. So this is y equals negative 2x and a positive 1. And again, we can't combine those terms because they're not like terms. So keep them separated like that. Now, what does this give us, slope-intercept form? Well, it gives us a slope, which is the coefficient of x, and in this case, the coefficient of x is negative 2. I'm going to make it negative 2 over 1, just so that we can see that it's down 2 to the right 1. Now, the y-intercept on this one, so here, y-intercept, it's going to be at 0, 1. Right, it's y equals mx plus b. That's the plus 1 right there. And that's a point I can put on the graph pretty quick, right? So there's 0, 1 right there. And then the slope being negative 2, 1 means I'd go down 2 to the right 1, which gives me my next point. And like I said before, you know, this creates kind of a staircase, which gives us all the rest of the points on the graph. And of course, when you're doing this on the quiz, it'll be on the computer, so you'll only need 2 of the points. All right. Now this is just that first line, by the way, and you can see I'm copying that staircase to the left as well, which goes to the left 1 and then up 2, which is the same staircase. And it needs to be. Now again, whether you connect the points at this time or later is up to you. I connect them later because I fully expect the second line to find an intersection at one of these red dots. So the second equation, we'll graph that in green, so I'm going to put the table in green as well. This is for the second equation, right? Negative 3x minus 6y equals 12, and this may be more rows in the table than I need, but whatever. I'm going to say, well, what if x was 0? Let's see what that does, okay? So then that would zero out the negative 3x. You'd end up with negative 6y equals 12. Divide both sides by negative 6. You get y is negative 2. So 0, negative 2. Now that's right there. That's on the purple line, but it needs to be with the red one, right? So what about when x is, well, let's say y is 0. I think that should work. Well, if y is 0, then it'd be negative 3x equals 12. So divide both sides by negative 3, and x equals 4. So that'd be 4, 0. Let's see, 4. No, that's negative 4. I'm sorry. Negative 4, 0. That's better. Well, I guess it's looking good, but this is I think it's gonna come out kind of weird. Let's continue and see if we can find something that works. What about when, I guess, I don't know, if I say x is 1, that's not going to work. What if x is 2? What does that do? You get negative 6 minus 6y equals 12. So add 6 to both sides, then it's 18. Negative 6y equals 18. So y equals negative 3. Oh, that's why I graphed it in the wrong place, dang it. I put that first point at 0, negative 1. It should have been at 0, negative 2. Oh, okay, so that makes sense then. So I got a point at 2, negative 3. Oh, there it is. Okay, again, you should be able to see that pattern right there. It would go through this point and this one and this one and this one. Okay, so yeah, that was great. Because I graphed it wrong, it was throwing me off pretty bad, but we can see now that it's going to work. And what is that point of intersection? It's just this one right here, which is at the point 2, negative 3. So now, of course, if you're doing it by hand, I would probably connect these points right here, right? So there's that one with the green points, and then the red one. There we go.